Hello, hello, hello. We are doing 7.3, number 1. Now, the way this problem works is like this. I am here. Now, imagine I'm in space or something. Okay, here's my little spacesuit. And I'm out here in space, and I'm not in orbit, but something is orbiting me. The thing that's orbiting me is an apple. And final little feature there. There's an apple. It's in space, and it is orbiting around me. It is going around me. And the distance is going around me. The radius here is approximately 0.5 meters. It's a very tight, close orbit around me. And what I'm trying to figure out is, what is the period of time? How long is it going to take for it to go around me? So let's start out with our formula. T, which is the period, is equal to 2 pi times the square root of the radius cubed over big G, which is the gravitational constant, times my mass. Now, just thinking about this, big G is a very small number, isn't it? And small numbers in denominators result in big numbers, right? So it's probably going to be a pretty slow process of going around me. The reason why is I don't have a lot of mass. I'm not a planet. I may seem like a planet because I'm a big guy, but I ain't that big. And which means that the apple cannot go very fast at all, or it's going to escape my gravitational pull and fly off into space and I'll never see it again, which could be a problem because if I'm going to be in space, I could get hungry. I might be out here a very long time. So let us proceed with our equation. Now, big T, which is what we're trying to find, is equal to 2 pi, 3.1142, something blah, 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 something like that. Then we got the square root of r, which is 0.5 cubed, over 6.673 times 10 to the negative 11. Make that line longer, times my mass, 108.9 kg. And your mass, of course, will probably be smaller than mine, but it might not be. Depends. You know, most of us put on some pounds during the holidays. All right, so we just keep going here. T is equal to, multiply this by each other, and I get 6.283 square root. 0.5 squared is 0.25. 0.25 times 0.5 is 0.125. Over 6.6. Let's see, do I multiply this? Yeah, why not? Let's just multiply this by each other right now. Now, I'm going to multiply this times my mass, which gives me approximately, see, I've already got it written it down. Okay, so I get 726.69 times 10 to the negative 11. So I just multiplied that part times that part and just forgot about this part for now. Now, what am I doing with that? Well, what am I doing with that? Oh, okay, so here's what I'm doing. T is equal, this stays the same. Now, what am I doing here? I'm going to take this number and divide it by 700. And then we'll talk about this in just a second. So 0.125 divided by 700, and I get an extremely small number, 0.0000172. Now what I'm doing, and then another 0, times, now here's the thing, times, if this is on the denominator and I want to move it up to the top, I just simply take the negative out. So times 10 to the 11. So this really small number times that, and if I want to just do that, I can just do this. How do I get rid of this 10 to the 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I end up with T is equal to 6.2 283 times the square root of, move that over, 172, and then 5 zeros. I think that's right. 17,200,000. See, I basically just took that, put that in there, and then I'm going to take the square root of that. By the way, since we're running out of space, just bring this up here. T is equal to 6.283 times square root of that, and I get 4,147. 4,147. Multiply those two together, and T is equal to approximately 26,058. Now, 4 sig figs, 4 sig figs, 0.5. Let's just assume that was completely precise. 4 sig figs, 4 sig figs, 4 sig figs. We got 4 sig figs, which is a lot for us. So we're going to round that to 2. T is equal to 26,060. Now, what units are T in? Well, the answer is the same units they're always in. They're in seconds. Now, 26,000 seconds, do you really think about 26,000 seconds? Probably not. So let's turn this into hours. There are 3,600 seconds in an hour, so if I divide this by 3,600, that's the number of seconds in an hour, and I end up with T is equal to approximately 7.2 hours, which is a long time. I mean, think about it. You got that apple. The apple is going around here 7.2 hours later. It has gone around me once. The pull of gravity, my pull of gravity is so weak that if it went any faster, it would fly off into space and I'd lose my lunch. So it's a very, very, very slow orbit. But it would go around me. Now, let's think number sense. What about you? You're probably not as big as me, which means you're going to have less gravity, which means the apple will not be able to go as fast, which means it's going to take longer for that apple to go around you than it did to go around me. So expect a longer period of time than 26,000 seconds or 72 hours. By the way, either way would be right. If you want to put it 26,000 seconds or whatever number you get, or you want to change it to hours, that's fine too. But it's going to probably take considerably longer for that apple to orbit around you, because if it went that fast, it'd probably fly away. You wouldn't have enough gravity to keep it there. So anyway, just wanted to let you know what our situation was, and hopefully you'll get the answer, and hopefully that'll make you happy.